Everyone. Today I discussed with a girl. She showed me her exercises solutions, and I found that usage of the quantifiers for all and their exist is not up to the mark. You seem to have some confusions in using for all and their exist quantifiers, especially these two. So since you have an exam shortly, which is tomorrow, and there is no time to meet you all and tell you, I use this medium of video recording, and I'll give you some more examples in this, which will probably help you to understand when to use for all and when to use their exist quantifiers. Okay, very simple example. Let's take a simple example. You all know that for any integer n and any integer m, n plus m is also an integer. You all know this. So how to write this using the quantifiers? So what you should do is, for all n comma m belongs to integer set. Hold on, this is not writing well. Just let me write it in a better way. So for all n comma m belongs to integer set, n plus m belongs to integer set. So this is the way of using it. So you take any integers n and m, their sum n plus m also belongs to integer set. So you have it in your mind, but you should write that in using this for all. Suppose I'll give another example, normal conversational example. For all scooters, there are two wheels attached to it. So you know this, every scooter has only two wheels. So how do you write it? So for all, S small s belongs to scooter set S, capital set of all scooters, small s is an element of that. S has two wheels. Okay, two wheels. That's all. Two wheels. So whenever something is happening, some property is happening, for all events, for all elements of a set, then use for all. You can also use for every also. The for every is even more appropriate, but there are subtle differences. I'll tell you in the class when to use this. Next, there exist. So how to use there exist? Suppose I say that all students of this BTech maths and computing students of this class are intelligent. I am saying this. So all students of this mathematics and computer science students are intelligent. Then how do you disprove it? If you want to disprove this statement, then what do you say? Disproving the statement doesn't mean that you should prove all of them are not intelligent. You should prove only one element of this class or one student of this class is not intelligent. So how to write it? There exists one student who is not intelligent. That's all. So whatever you think logically, and you can apply this in mathematics. Think logically. When will you use for all and for there exist? If I say all elephants are black, that means what? If you have my elephant set as E, then for every x belongs to E, or for all x belongs to E, x is black. X is black. So this will be my statement saying that all elephants are black. This is in English, but if you want to write that in mathematics, if E is a set of all elephants, then for all x belongs to E, x is black. Now you want to prove that this statement is wrong. If you want to prove that this statement is wrong, then what you do? You have to say that there exist some elephants which are not black. So how do you prove? So you have the negation of for all is there exist. So there exists an elephant, an X belongs to E, and X is not black. Not black. Got it? Very simple. So always remember the negation of for all will be there exist, and negation of there exist will be for all. So if I am saying that there exists a student of your class who is not intelligent, it means that if you want to negate it, then for all students of your, every student of your class is intelligent. So how to write? For all X belongs to this class, X is intelligent. So I'll give a couple of more examples again. Now you know that if you add any two positive integers, the result also will be a positive integer. You know this statement from long time, from your childhood actually. So you add any two positive integers, the result also is a positive integer. So how to write this? For all n comma m belongs to positive integers, n plus m also belongs to positive integers. That's all. So this property n plus m belongs to positive integers, this property is true for all n and m. So therefore you use for all. If some property is true only for one or two elements, or one, two, or some elements, not for all, then use there exist. Suppose you want to say again that if I say all positive integers are perfect squares, if I say this statement, all positive integers are perfect squares, it's a wrong statement because there are also integers which are not perfect squares. So how do you write it? There exist n belongs to integers and n is not a perfect square. Not a perfect square. Okay. So you think in mind whether you are using for all or for there exist. You think and you write a statement in your mind in English or in your local language, and you convert that into mathematics. The majority of people, what you are failing here is this example. If n is even, if you know that the number n is even, then it is a multiple of 2. And you know this. But how to write it? How to write it mathematically? If you have a number n with you and you know that it is even, then what? Then n will be an element of 2, 4, 6, 8, 10 of this set. That means this particular n will be 2 times something. 2 times something, some integer. That means what? There exists an integer. There exists. Now you should get in your mind, okay? Because n is 2 times something, that means that something is there exist. There exists an integer. So if you know that n is even, you use there exists an integer x belongs to the integer set such that n is equal to 2 times of x. Here you use there exist. I found that couple of students, after talking to a couple of students, you are using for all. If n is even integer, for all x belongs to z, then n is equal to x, which is absolutely wrong. Because n is only one integer you have which is even to you. It is given that it is even to you. If only one integer that is n is even to you, if you are given that integer with you, or you have that integer in your hand, then it will be only one integer, one even integer. So it could be either 2, it could be either 4, it could be either 6 or any number. Therefore, there exists some number where this n is a multiple of 2 of that number, which is x here. Clear? Now you want to, suppose you want to prove this. Suppose you want to say, you take any integer and multiply 2 to it, it will be an even number. So you take any integer and multiply 2 to it, the resultant will be an even number. So how to write using this? So you write, for all integers, for all n in an integer set, 2 times n is an even number. Times n is an even number. So here you are using for all, because this is true for all n actually, not for one n. For any integer, this is true for any integer. So you take any integer and multiply 2 to it, the result will be an even integer. Therefore you use for all. For all n belongs to integer set, 2n is an even integer. Okay? Understood? Any questions? You're not replying, so I think you understand it. Thank you.